Hello, everyone, and welcome to the March 2019 session of Dr. Spotfire. Today, we'll be presenting on using TERR and Spotfire 10. A quick word about TIBCO. TIBCO is a global technology leader who, for the past 20 years, has helped thousands of customers across various industries. We enable smarter decision-making through data, whether you need to integrate or analyze that data. TIBCO is here to help you with your digital journey. Here at Dr. Spotfire, our slogan is learning is not driven by answers, but by questions. And today, our Dr. Spotfire lab is located in the Seattle, Washington area. We have customers attending from all over the globe today, and our team is based all around the US. My name is Neil Kanungo, and I'm the professor for today. We also have Ninad Sawe as a panelist. Ninad helps put together lots of webinar series, events, and feature sessions. Robert Brashenko is also on the call today. He helps with post-processing of the session, including summaries on the TIBCO community. And Anya Afalenko is our campaign manager, and she makes sure you can register, get reminders, and have access to these sessions. Today, Robert's going to be presenting on taking advantage of TERR and Spotfire 10. Throughout the session, feel free to post any questions you have in the webinar chat or the webinar Q&A.
Hey, thanks everyone for joining today. As Neil mentioned, we'll be covering how to take advantage of TERR within Spotfire. I'm sure many of you are aware, TERR is TIBCO's enterprise runtime for R. It was built to really address the limitations of R, as you know, the creators did not really design for the enterprise or the vast amounts of data today. So there are often, performance issues with big data and poor memory management. TERR was actually designed from the bottom up to scale to your big data and enterprise needs. Additionally, TERR is a component of TIBCO data science. Today, we'll start off with a brief introduction to TERR and Spotfire. We'll cover some use cases that are available on the community. We'll dive into two different demos, one that applies the data function, another one is an expression. And finally, we will go into some debugging tips. So Spotfire Desktop Analyst actually includes a local TERR engine. This then computes your data functions using your own computer's memory and processor. You can also use TERR engine within your Spotfire server environment to do the computing, outside of your desktop. For instance, anytime analyses are viewed from web consumers, the computing is always done using your Spotfire server. Additionally, you can utilize R, MATLAB, SAS, or other components of TIBCO data science within your analysis. There are several different ways of taking advantage of TERR within Spotfire to build your analytic apps. The first way you'll notice is using just adding statistics to your visual environment. Anytime you right click and you use a forecast such as Hope Winners that uses TERR. The next way is within expressions. So this allows you to wrangle your data using R directly within Spotfire. You can use built-in expressions, which there are several, which we'll be seeing later, or you can even register your own. The most common way TERR is used within Spotfire, I'd say, is through our data functions, or specifically data functions in Spotfire, which can take advantage of R scripts, SAS, or MATLAB. The inputs and outputs are complete and full Spotfire objects, which you can do any of the normal things that you can do in Spotfire with. There's also all the built-in tools menu that include the machine learning functions, such as the classification, regression, clustering, line similarity, and data relationships. Additionally, you can extend your Spotfire graphics palette. We'll start getting into some of the use cases that are available on the TIBCO community. So we have here is a Spotfire data function that uses the R function contour lines. the result is then pushed back onto a Spotfire map chart. The Spotfire map chart does accept this object from TERR data function and displays directly on the map. A pretty common and popular example that we see with our customers is in the semiconductor industry. Data functions can actually construct wafer map charts. So, the first data function creates this map chart that then becomes part of the regular Spotfire collection. Then additional data function is used right here to do the smoothing on the output of the first data function. Oh yeah, and this TERR data function uses an interface to the HTO system. This is again available on the community. The relevant R function here is the H2O deep learning. Additionally, there's several other machine learning algorithms available on the community, ranging from gradient boosting and random forest to anomaly detection. Customer propensity accelerator is available, and various optimization and genetic algorithm use cases. So in a second here, we'll jump into the first demo. Hold on while I change desktops real quick. And we'll be starting with the CSV actually. So what we have here is a CSV file just containing longitude, latitude, and a Z value. Z really can just represent any data point of interest to your organization. The first thing we're going to do is just plot this on a map chart. You see that it instantly populates the data on the map chart. But we're really interested in applying some more geospatial analysis on this, and we are interested in the contour lines, which is the one shown earlier. This data function is available here on the community, and everything that you need to know in order to use it is available. It's very well documented and very well tested. So to start off, one of the big things about Spotfire and TERR is the painless interactivity between the two. You can go ahead and select some data here, and we're going to go ahead and then register the data function that I downloaded from the community. Just drag this over here and import this SFD file. right off the bat, we have the script, we have the input parameters, the X, Y, Z, and additionally, we have a smooth scale. The smooth scale determines the degree of smoothness that we will create these contour lines for. Output is a simple data table. You actually go ahead and see in the R script itself where the input is and then how the various algorithms are applied to it. A tip though, I would say when creating your R scripts and your data functions is to make sure that you encapsulate all the commands within a function. It just makes debugging easier, which we will get into later. Down here, you can go ahead and see that then the geometry for the contour lines is exported into the data table. So what we'll go ahead and do is run this data function. So what we're doing here is mapping those exact inputs that we just showed. So we're interested in limiting it by the marking. And we'll then have to go ahead and do that for each one of these. Finally, the Z. And since the smooth scale is a value between 0 and 1, for this example, we'll just start with 0.5. You can actually decide if you wanted to run this on your local environment or in your server. And you could, of course, set a default option as well. The output here is going to be the data table, which is all set to go. All right, so nothing happened, but it's okay. There's no error. So the new data table was created. So we can go ahead to our data and analysis panel. And we have the contour lines here. Go ahead and drag this right over to the map chart. And we can just, by placing it here, it creates a new feature layer using this column. And you see the contour lines are added to the map chart. Of course, you could color by this, just do the default level and auto bin it, but you can, create custom expressions that determine the coloring as well. But now if we wanted to go ahead and select other data, there was an option that I passed on, which is being able to refresh your data function automatically. So if we wanted to go ahead and select new data and we wanted that data to be the new input for the data function, we'll have to either mark that before we run it, or you can go ahead and go to data function properties and edit the parameter here and go ahead and check this refresh function automatically. And so what that does is it allows you to go and select any data of interest, and it will compute the contour lines data function with the new input. And so that was actually our contour lines data function. Sometimes if you don't select enough data, it won't be able to calculate. But so for our next example, we are actually diving in to, and that was of course using a data function. So now we'll be diving into the expression using TERR within expressions. What we have right here is US Census Bureau data. There's a shape file, as you can see in this data table, for all the different geometries. Then additionally, we merged in some data such as college graduate level, median age, and median income. So yeah, of course, right off the bat, you can go color by this. But what we're really interested in taking it to the next level and combining those three columns into a k-means algorithm, so we can get a better idea of the clustering of the populations. So what we're going to do to calculate that is we're going to create a new calculate column. And the calculate column I already have saved here. And what this does is it uses this statistical function that is built in already. A spatial function, statistical function, and it's a TERR integer. So basically it just returns the values of the first parameter, which is actually an R script that calculates the k-means. So the k-means algorithm takes in these three inputs: income, age, and college graduate level. And then we use the TERR integer function, which will then create the four clusters. And then we cast it by string because we're interested in these being categorical data. So we'll go ahead and name this cluster. And it runs just perfectly. So we can go ahead and now color this by our new column here. But while this is great, we do have these four clusters are color-coded across the state of California. We could definitely use some more context. So we'll go ahead and create a bar chart. We're not interested in row count, but we are interested in the three columns of interest here: the college level, age, and income. But we do want to aggregate this by average, which you can see there are several different aggregation methods available. We'll have to go and change this to, to column names. All right, we're starting to get somewhere, but we're more interested in seeing this data in each cluster. So what we want to do is trellis the bar chart by the cluster itself. And to color code it nicely, we'll also color it by the cluster. So now that's a little better. So now we can start understanding what the clustering means. You can see here that the cluster containing the group of people with the highest age, you can see that they're, where they live. We can see that the people with the highest income live in the metropolitan areas. And we also see that the cluster with the highest income is also the cluster with the highest college degree. And so these are just a few of the insights that you can just extract by applying a more advanced geospatial analysis using TERR expressions. So that was indeed the expression demo. So we showed two ways of utilizing TERR within Spotfire. Now we're going to show you tips on debugging, because when you're writing your R scripts, of course, at some point you're going to have to debug. First, I want to show a resource that's available off the community. This is top 10 tricks for TERR data functions. I'm sure if you just Google top 10 tricks for TERR data functions, you'll find it, but the link is also available from the community. What we're interested in in this list of tricks here is being able to debug data functions in RStudio here. So what this gets into is, well, let's jump right into it. To begin with, anytime you want to do debugging, you're going to want to go to your options and go to your tools. Go to your tools and then go to your options to data functions, excuse me. And so here you see you can decide if you want your default setting to be your Spotfire server environment for computing TERR, or for your locally installed runtime that's included with your desktop analyst. But you also have this option to enable data function debugging. This option is useful as it'll give you all the details and all the information that is exchanged between Spotfire and TERR. It is not enabled by default just because naturally it does slow down performance when you're dealing with a vast amount of data. But another useful way of debugging your script, especially if you have it working in your development, your IDE of choice, your environment that you develop your code in. One way to see that you can, easily debug what the differences between the two may be is by going ahead and going to your data function. You can edit the script here. Let me drag it over. And there's a couple of lines of code that we can add to make debugging easier. The first one, we'll go ahead and it will create our data file. And within this our data file, it will contain all of the information that you have of interest. It will contain all the information in this analysis, or that it's being sent to TERR, and you can go ahead and open that within RStudio. But additionally, you can add a timestamp. By adding this timestamp, you have the ability to make sure that your code is running at the the proper order that you're expecting it to. So we'll go ahead and save this. So now we just have to go ahead and select some data, and now our data file is created in the the directory that we specified there, which is just my local disk, and we can see that right here. But what we're going to do is we're going to go ahead and open that in RStudio. Before we do that, though, it's important to note that you can actually bring TERR's runtime into RStudio. And you do this by going to the global options, and under your R version, you go ahead and change that to your TERR environment. We'll have to restart RStudio really quick. Great, and so now you can see that TIBCO Enterprise Runtime for R version 4.5 is being used. So what we'll want to do is go ahead and load in that debugging file. Now you can see all the data within that is brought right into RStudio, and we can go ahead and it makes it very easy to debug where your errors are. But especially what really does help a lot is being able to see, where the timestamp was for that line, where I inserted that line. Of course, I must have spelled it wrong, so let me just double check. excuse me, go find what I labeled that timestamp as. And these tips and tricks are available on the community in case it doesn't work now. There are step-by-step examples available online, which we can link to after this presentation is posted. But we'll go ahead and select some new data. Okay, we updated that data with the new file that was saved when we selected it. And there we go. So what the mistake I made was I created that timestamp after saving the file. So it wasn't actually saved into the file. So you're gonna want to make sure that when you do create a timestamp, that is before before you save that file. But yeah, so this is very useful, being able to see when your code is being run. And of course, you could put this throughout your entire script and within different functions. And then when our data file is saved, you can see, okay, when is this being hit? And that is the end of my that is the end of my debugging tutorial. There are, of course, more information on this available online. And that's what I have today, Neil, if you're ready to go.
Yeah. Thanks, Robert. That was a really good demo. I think for me, TERR really opened up a lot of Spotfire for me. It really expanded Spotfire past just simple reporting or dashboards. And I really like the map example you showed. I think it really shows the power of being able to calculate something dynamically rather than pre-calculate all of your results outside of your visualization tool and then import them all in. With that contour plot, you showed that TERR can calculate just based dynamically on your markings and only the data you need. While you showed that with maps, I hope the audience can infer that you can also do this with all kinds of data functions and scripts, even just analytical scripts that produce tables of data, predictions, regression analysis, all types of statistical functions. So, Robert, thanks for that demo. I'm gonna share my screen now. Robert mentioned the tips and tricks page. I put this in the chat for the webinar. And there's also on the community these tips for debugging. It shows some tips for how to create more readable code, some special cases, things like this with debugging. So make sure to check that out on our community. The community also has an exchange that Robert had mentioned where he had gotten the map contour data function. You can find that data function, other data functions, templates, and even accelerators, which involve multiple TIBCO technologies, all right here for free on the TIBCO Community Exchange. I have a question in the chat about how do they scale when the data sets become very large. And with TERR, TERR is up to like 8,500 times faster than R. It's built from the ground up by TIBCO, so it scales very well. You can run multiple TERR engines in your Spotfire environment, and you can definitely scale these for big data, billions of rows, lots of large data sets. So it's good to try when you're developing a script, to try it on your desktop, and then if you're getting to larger data sets, go into your server environment, talk to your administrators if you need to see if there's a good test environment if you're using really large data. So Tessa Klein also asked where the recording will be posted. So I'm willing to talk about our Robert, can you see my screen? Everyone can see my screen, correct?
Yes.
Okay, just making sure. It's been a little weird. So on the community, there is the Dr. Spotfire office hours page. This has a log of all of our previous webinars. It also has the registration link for the next webinar. So today was the March one. A new change we're actually doing is that we are putting the webinars for 1 month. They'll be on our on-demand page on the TIBCO website. So you can go find it at this link. And then after 1 month, it'll go into the YouTube channel and it'll be in the Dr. Spotfire playlist right here on the channel. So you can subscribe to this and get new updates whenever they get posted to YouTube. You can find both those links on that community page I just showed you. We also do a Q&A session, but we're kind of changing the nature of Dr. Spotfire now, where rather than go into a bunch of detail in the Q&As, we're gonna we look at all the Q&A, all the questions on the community over the month, and we try to come up with a single demo or tutorial that addresses multiple questions. So if you do have questions, you can post in the community with hashtag Dr. Spotfire. You can tweet with hashtag Dr. Spotfire, or if you have sensitive data, you can email to drspotfire@tibco.com. So for today, I'm going to do a Q&A on why you should unpivot and pivot data. So people are asking questions that don't necessarily don't explicitly say unpivot or pivoting data, but when you look at the questions, you realize, hey, if this person would unpivot their data, it would solve a lot of their problems. So I wanted to go a little bit into why we would do that. So let me see here. I have, okay, so first thing, give me 1 second. Okay. The first thing I want to talk about is that your data set, just a quick background, your data set should have each observation as a new row and each variable as a column. So you want to try to orient it this way. And that's a good, clean data set. Now, that information may not be enough to construct a data set, because there's different ways you might decide to determine what is your variable, what are your observations. So for instance, in this example, where let's say we have a weight loss competition in the office. So we have Joe, Sally, Jill, Mike, Alex. And so for observations of Joe, we have in January 2018, his weight, February, March, April, etc. Right? So this is a common way to show this, but it's also not the best way for data analysis. And the reason is because if I have a new month like June 2019, then I have to add a new column here and add the new values, you know, and then for July, I would have to do it again. July, I'd have to do it again, etc. And so I keep having to add new columns, and that's going to actually change the structure of my data. And once that changes the structure, then it's going to change how that data is processed by other applications. So another way to show this is by unpivoting it, where I would have the name in one column, the month in another column, and the year in a column, and then just the weight. So what this means is that whenever a new month happens, I can just put in Joe, and I can put in June in 2019, and I can put in his weight, and I can just keep doing this for all of the new records, and I don't have to actually change the structure of my table at all. Now, this isn't a really easy way for a human to view this data, because it puts it all really narrow. This is called a tall and narrow data set. So it could be harder for a human to read this. And so typically with Excel, people would do things like this and kind of put this in kind of other matrix form. But, you know, when you're using something like Spotfire, you don't need to have it easy to read in your data source. You want it to be easy to use from your data source, and Spotfire is going to be the visualization layer on top of it. So now I'm going to show you an example where I have a bunch of sensor data. So I have like 14 sensors, and I have a timestamp. And so this is for some manufacturing plant or some equipment out there. I have all of this data, and these are each sensor, of course, as you can see, in a new column. So if I show this in my DXP, there's that same data brought in. And if I try to chart this I would have to keep adding each new sensor in here, right? And what would happen if I got a 15th sensor or a 16th sensor? Then I would have to come back into my analysis and re-add all of this stuff. Adding all of these columns isn't really that scalable. And then also, because all of those dimensions are in their own column, it's hard to use other charts. Like if I try to use a pie chart, I can't like sector size it by, can't do the sector sizes by like sensor, for instance. I would have to keep adding a new column here as well. So as an alternative, a better method is to take the data and unpivot it. So what you can do is right in your data canvas, you can take your data and you can add a transformation for unpivoting. And the column you want to pass through is a timestamp, and the ones you want to transform will be each of these sensors. And you could just name the category like sensor and then just have the value here. So this will put them all in the same column for you and the values in that other column. I'm gonna hit cancel because I've already actually added this to my transformation here. So now that they're actually all in one column there, I can, instead of having to add each new sensor, I can just put the value here for this axis, and I can have each individual sensor as its own. Since it's an own column, I can just color by each individual sensor. So I have them selected here. And I have this where I can now select different sensors easier because they're all, again, in one column. But let's say I wanted to view all of the sensors how I originally had it with all of the sensors in different columns like this. I want to view it across. I want to see just for this timestamp. I want to see what everything looks like at this timestamp. I want to see what everything looks like at this timestamp, etc. What you can do is you can create a cross table. And I'm going to take a second to talk about this cross table. So the cross table you have for this axis, I can have each timestamp, and for this axis, I'll use the sensor column, and I have to choose an aggregation method here for the value. I want the values to be in there. I want an aggregation method. So why do I have to choose an aggregation method? Let's say in my sensor data, let's see in my weight loss data. Let's say I had this unpivoted data, and let's say I had 3 measurements for Sally in September. I had 3 different values here for September 2018. If I try to pivot this out, which of these 3 values would need to go in this one cell? I would only have one place to put a value for Sally in September 2018. So which of the 3 would need to go in there? In order to decide that, you can use an aggregation method like an average or a sum. Here I've just used the average value. So for the values that don't have multiples, that just have one value, the average would just be the number itself, so you don't really have to worry about it. But in situations where you have multiple values trying to go into one cell, using something like average will combine them together, or sum will combine them together. Now, let's say I wanted to do a calculation and I wanted to calculate a column, and I wanted to see like the average of all of these sensors at this timestamp. Well, I can't do that directly because now I have my sensors in this whole column. So the last Dr. Spotfire session, we showed how to use the over function. So in column properties, if you go here, I created this calculate column where I did the average value over each unique timestamp. And what that did is it showed for this timestamp, I have like 308.6. For the next timestamp, I have 309.65. And it now has done this average across all the sensors per timestamp. So that's another way you can show that, and then you can just use this column in your data. And the last thing I'm going to show you is how to do this if you have, this is all well and good if you have all these like sensors or columns and you know that those are fixed, but sometimes you can't control your data source. And let's say you have, tomorrow there's 15 sensors, and the next day there's 16 sensors, and then next month there's 22 sensors, and there's multiple columns that are in my source data, and I don't want to keep coming back in and doing their unpivot over and over. So blending off of what Robert showed with data functions, there's actually, I'm going to show a data function where I'm actually, so you go tools and I'll register a data function. There's a data function where you, let me see, I just opened from, I have it saved. Here it is, sorry, I couldn't remember where I had it. So there's a data function that uses the reshape2 package, and it uses the melt function. And what this means is it will do an unpivot where you put your pass-through columns here. So I just have timestamp, but I can also say if I have another column, I can say like column 2, I can say column 3, etc. So I can pass, those are my pass-through columns. And then everything after that, it'll unpivot and you say the variable name. I want the variable name to be sensor, and I want the values to be shown to be in the value column. So just like I showed with the other unpivot. So I can put an input table and an output table. So to run this, I'm going to use this input table. I'm going to bring my sensor data. And for search expression, if I just put an asterisk in here, it'll just bring in all of the columns that are in that data table. So right now there's 14 columns, but if there were 15 columns tomorrow in the data source, it'll still pull in, that 15th sensor, and et cetera. If there's 16 the next day, it'll just keep pulling in any columns that are available to it. And then output, I'll just do an output data table right here. And I'll hit OK. And close. Now I have an output table which is unpivoted. So that was all unpivoted from the data function. And again, if my source data changes and tomorrow I have, more sensors, they'll all scale. So if tomorrow it looks like this, they'll all work. So let me take one look at the chat and Q&A, kind of coming to the end here. Okay. So that's it for today's Dr. Spotfire session. Remember, you can find a lot of this information on the TIBCO community. There's a great wiki site. There's a question and answers page. There's Dr. Spotfire pages, TERR references. Be sure to check that out, and we hope to see you next time. Thank you.